Hello friends, welcome to our channel Knowledge Amplifier. So in this particular video, I am going to discuss one very important data pre-processing, or we can say image pre-processing concept before applying watershed segmentation. Okay, so for this particular discussion purpose, I have taken one image, binary image. Okay, blob you can consider, binary large object which is having this kind of shape. Now it will be very convenient for us if we able to convert this particular image which is having complete uniformity in this white part and complete uniformity in the black part. Instead of directly applying watershed segmentation on this to just identify these two different objects, what we can do, we can just apply distance transformation on this. What distance transformation will do? It will basically, if you recall our previous video discussion, like it will basically convert this image such that there will be some local minima will be there, and for watershed it will be easy for finding out that particular local minima and it can work perfectly. Okay, so before going ahead, let us try to understand what is distance transform. Distance transform is very simple concept in binary image processing. That is, you just try to find out the distance of a pixel which is having 0 value with the nearest non-zero pixel. Okay, like here you can consider this one, this one, this one, this one. These all are on pixel. These are on pixel. Now consider this 0. What is the distance in between this 0 and nearest pixel which is on? See, just adjacent to this. So distance is 1, right? So in place of this 0, we are putting 1. Okay, right. Now see, for all the on pixels, the distance from the nearest on pixel will be obviously 0, because if you consider this particular one, for this particular pixel, distance with respect to nearest on pixel will be itself. Okay, that is this position minus this position, whatever distance equation you are using. So 0 will be getting. Similarly for this on pixel also 0 will be getting. Similarly for this on pixel also will be getting 0, and for this on pixel also will be getting 0. Okay, now consider this 0. What will be the distance with respect to nearest on pixel? See, adjacent, so distance will be 1. So see, here we are having 1. Okay, for this 0, what will be the nearest distance? See, nearest one, either if you go downside this much you have to go. Okay, so 1, 2, more than 2 unit, and here actually 1 unit, 2 unit, 3 unit you have to go. In this direction 1 unit, 2 unit only you have to go, and diagonally also it will be more than 2 unit, right? Because here itself 2 unit, here 1 unit, so root over of 2 square plus 1 square, this will be diagonal distance. So anyway, you can understand that with respect to this 0, the nearest on pixel is this one. Okay, so 0 and 1. What is the distance? See, 1 unit, 1 unit, 2 units. So we are placing here 2. Okay, like that. If you consider this particular 0 pixel, the nearest one is this one, right? So 1 unit this side, 1 unit this side. So root over of 1 square plus 1 square, that is root 2, 1.14. See, 1.14 we are getting. For this particular 0 pixel, see, for this particular 0 pixel, if we go 2 unit below, we are getting this on pixel. For all other way, distance will be more, because you can understand if you go diagonally with this particular one, what will happen? 1 unit, 1 unit, 2 unit, then 1 unit. Okay, that is square root of 2 square plus 1 square you will be getting as this diagonal distance. Okay, but compared to that, this one is nearer, so distance is coming 2 unit, like that. So the main funda is in distance transform. What we do, we basically take our binary image, and for each and every off pixel or 0 pixel, we try to find out the distance with respect to nearest on pixel and place there. Okay, so what will happen eventually? The particular pixel which is actually far away from on pixel, that will be given highest brightness or highest intensity obviously, and those pixels which are closer to our on pixel, those will be having lesser distance value, so those will be kind of dark shape. Okay, that is the main idea of using distance transform before applying watershed segmentation. So what I'll be doing, I'll be applying my distance transform on this particular image. Okay, right. So here first I will be writing image equal to bwdist. Okay, this is the function to apply distance transform. I am passing my binary image, I am giving figure, and I am show image. Okay, let's run this particular piece of code and let's see how distance transform is generating the image. Okay, right. So here this kind of shape we are getting because this is in double format, it is returning. Let me write unsigned integer 8-bit representation, and let's run this particular piece of code once again. Okay, so see, like this way we are getting. Now try to understand why we are getting like this. See, all these are on pixel, so distance nearest pixel, nearest on pixel is itself, so distance 0, so this particular part is completely dark. And if you go away from this blob, the distance with respect to nearest on pixel increases, so as a result in these two parts we are getting brightest side, because you can understand here whatever pixel present, they are actually farthest from the on pixel, right? But we don't want this kind of shape, so we want that at the central part, the central part of the blob, the minimum will be placed, so that we can apply watershed segmentation and go through the algorithm. Okay, right. So if we just take complement of this image, let us just check what is the complement of the image. If I just run this particular piece of code, see, so see, for this particular image you can easily understand that if you apply distance transform on this, what will happen for these two binary different objects which are basically connected. You can understand at the central part the distance with respect to on pixel is maximum. Okay, and for all the these pixels which are in border, with respect to those, the distance for on pixels, nearest on pixels is less. So basically if we apply distance transform on this particular image, what will happen, that intuitively we can say that this at the central part the brightness will be maximum, and at these particular border parts the brightness will decrease, and at all this white part brightness will be 0, that is completely dark pixel will be getting, because distance of an on pixel, if you apply on an on pixel, if you apply distance transform, you will be getting 0, because you can understand that minimum distance with respect to itself is 0, right? So let's run this particular piece of code and let's check. So here if we run, sorry, here we have not replaced x equal to complement of x. Now let's run this particular piece of code and see how we are getting. But this is the reverse thing what is required for our watershed segmentation. This central part is actually maxima of the two legs we are getting, but we should get this as minima. So what we'll be doing, we'll be simply write like this: ms equal to 255 minus of uint8 of ms. Okay, and here no need to convert again. So basically what we are doing, we are basically taking negative of an image. Okay, and let's see, Control A, evaluate selection. So see how beautifully we are getting the image. Okay, so you can understand now on this particular image you can easily apply watershed segmentation, and watershed line or ridge line should appear somewhere here. Okay, which is basically differentiating these two legs. You can understand that here one minima will appear and here one minima will appear. So if you rain whatever will fall in this region will accumulate here, and rain whatever fall on this region will accumulate here. Okay, and when there is a possibility of merging water belonging to two different lakes, so then we will be creating one damp or watershed line. So our watershed segmenter will be able to differentiate these two objects hopefully, right? So let's go through the watershed segmentation in our next video. I hope you have understood this. Distance transform is a very important thing if you are applying watershed segmentation. Okay, I hope the importance you have understood, and this is very simple transform. Just what you have to do, take your binary image, for each and every off pixel you just try to find out the nearest on pixel and calculate the distance and put the distance in that position. That's all, right? This is all for this video. Thank you.